Thank you very much, James. Um, I'm going to be talking for about 35, 40 minutes, as James said, about zinc and retrofit. I'm going to start with a little bit of a story history, which is a bit of a story of retrofit. But just before that, the first image that you see on the screen there is actually a renovation retrofit of a college in Newcastle that was done about over 10 years ago now, and uses zinc standing seam as a sort of a wraparound going from the vertical wall to the low slope standing seam roof in two finishes, in the dark anthrazinc and then the lighter quartz zinc. But a little bit more on that later. So zinc is an element and it's been around forever. But the story of zinc as a material used for roofing and wall cladding sort of starts with these two people. The person on the left is Napoleon Bonaparte, and the person on the right is Jean-Jacques Dony, who is a sort of an abbot come chemist, and he received a patent from Napoleon to extract zinc. And this was happening at the beginning of the 19th century, so well over 200 years ago. Jean-Jacques Dony didn't have an incredible sort of success story. Technically, he managed to extract zinc, and one of the things he did is he built a bathtub that you can see on the left, which was Napoleon's bathtub, which apparently 6 soldiers carried all the way to Moscow and all the way back again, and it is actually can be seen in a museum in Liège today. On the right, though, probably more importantly, is he showed this material to a company who decided to use it as a roofing material on St. Bartholomew's Church in Liège. And that church still exists and still has a zinc roof on it. But what really made zinc take off was with these two people, Napoleon III on the left and Baron Haussmann, who was the town planner for Paris in the middle of the 19th century, so the 1850s. And this is sort of where the probably one of the biggest renovation retrofit projects of all time comes in. Paris was a medieval city, but it was really, struggling. It had terrible sanitation or no sanitation, terrible streets. And Baron Haussmann was given the task of taking sort of 12th, 13th, 14th century Paris into the 19th century. And on the left, you can see some of the drawings that were created at that time with the mansard roofs and the grand boulevards. And on the right is a picture actually taken last year. And if you went to Paris in 1860 and you went now, you would see relatively little change. What we see and what we know of Paris in 2026 was all really built in the 1850s. And this is a view from above of a part of Paris. You might recognize it. That's the Arc de Triomphe and the Champs-Élysées. And you can see there's a very predominantly grey colour. That's because nearly all the roofs of central Paris are made from zinc, or at least have a significant amount of zinc on them. Sometimes it combines with slate, but they are zinc. And there on the right, you can see that's actually the Boulevard Haussmann, which was named after the town planner, and that has all those roofs are zinc. I did once go to Paris with a UK architect, and we were in this exact position, because this is you can get to this place and look over Paris. It's from a shop called Galerie Lafayette, and the architect said to me, "I didn't realise that there was so much lead used in Paris." And none of that is lead. All of that is zinc. A lot of it uses sort of batten type systems, which we'll come to later, but all of it is Paris. As I said, sometimes combined with slate. Some people say, well, what's VMZINC? VM actually stands for Vieille Montagne, which is old mountain, which was the original mine where the zinc was coming from, which is now in modern day Belgium. That mine is long since shut, but the name of the company is VMZINC, and it was founded in 1837. This is something that happened in 2024. I'm sure everybody's heard of UNESCO. Um, uh, the zinc roofs of Paris weren't given UNESCO World Heritage status, but the skill of the zinc roofer and the zinc ornamentalist in Paris was given UNESCO World Heritage status. So the people that actually fit zinc have a UNESCO World Heritage status. Now, whilst this is sort of aimed more at Paris, I think all zinc roofers from all around the world can take a certain amount of pride in the fact that their skill has been recognized by UNESCO. And an awful lot of these projects, especially in Paris, are about retrofit. The buildings aren't being demolished. They sometimes get slightly modified. Sometimes the roofs get improved insulation, and then zinc gets put on maybe after 70 or 80 or 90 years. We'll come to the durability in a minute, though. In fact, we're going to come to it now. So zinc lasts a very long time. Typically, the BRE give a service life of 100 years. Now, zinc used to suffer from a little bit more corrosion, and you might ask, why was that? Well, basically, the thing that really attacks zinc is SO2, acid rain. Now, we have a number of environmental problems in the world today, but acid rain has actually been dramatically reduced over the years. So if you go back 40, 50, 60 years, corrosion rates for zinc were something at around about 6, 7, or 8 microns per year. Now, the thinnest sheet of zinc that you'd use on a roof would be 700. So it's still only 1% of the thickness per year, but it was significant. Today, we're down at 1 or 2 microns of corrosion per year, as I said, for a 700 micron thick sheet of zinc. So corrosion rates have actually reduced dramatically. This is a sort of first project to show you. It was done, first of all, it's done in 1879. This is Liverpool Central Library, which had a zinc roof. It's in 1879. And it was replaced about 14 years ago with another zinc roof. Hopefully that's going to last into the 22nd century. Liverpool, when it was this was installed, was a pretty dirty place. A lot of acid rain by the coast, so a very aggressive environment. But the zinc did last 130 years. You can see there on the left, it's the Picton Reading Room, which is a beautiful space, and that's where the zinc covers that area. There were some slight modifications made. English Heritage wanted a sort of it to go back exactly as it was done in the 19th century. Panel widths have been slightly reduced, or there were less rules then, slightly more rules now. So we didn't recommend the 800 millimeter wide panels. We recommend they be reduced a little bit. So between the batten caps, we've added a standing seam. So just to sort of make it even more secure than when it was done originally, although that roof did last, as I say, 130 years. I've mentioned obviously zinc a few times. What we're using here is basically 100% zinc. It is not galvanized steel, it's not coated, it's zinc all the way through. However, we do add, for about every ton, 1,000 kilos of zinc, we add about 1 kilo of titanium and copper, and that slightly increases the tensile strength. And the process that we're doing, where we're putting the zinc and that tiny bit of titanium and copper in a big oven, and it comes out as a liquid molten, and then it goes into the machine in the bottom left, which is called a Hazlitt machine, and it comes out as a slab of zinc, and then that gets rolled down to the thickness that's required, which is typically 0.7 for a roof, and then it can go up to 1.5 millimeter thick zinc for rain screen cassette panels. Whilst zinc is it's refined, it does need energy. A lot of zinc is produced through electrolysis, and that's done at room temperature. So the energy requirements are a little bit lower than other metals, which is obviously good. And zinc is never thrown away. About 99% of zinc that's old zinc that is then reused. There's a very efficient recycling system for zinc. Now, some of it might go to being used for a zinc roof or a zinc wall, but other uses are brass, galvanizing, zinc oxide, zinc for skin cream. Zinc is an essential element. It's not toxic like lead, so you can put zinc on your skin. In fact, it's good for you. A little bit about the aesthetics. This is one of the, as James mentioned, this is one of the real reasons why zinc's used. It's an attractive metal. It's not a painted metal. It just has the beauty of zinc, whether that be for retrofit or new build. So there's you can use mill finish zinc, we can pre-weather zinc, we can even engrave zinc. There's a number of options to slightly modify the surface. It is still absolutely solid zinc. Mill finish natural zinc can be used and is widely used and is still widely used in places like Paris and is used a little bit in the UK. On the left, actually, that's Hastings Pier that won the Reba Prize the Sterling Prize a number of years ago. It sort of had a not the greatest time since then, but it has a natural zinc roof. Now, natural zinc will form a patina, which will go to a middle sort of battleship grey, but it will take a number of years to create a completely uniform patina. So after a few months or maybe even a year or two, it might be a little bit uneven, which might be fine for some clients, but not for others. And that's where we have the pre-weathered quartz zinc, which is basically doing what nature does, but from day one. So it's this middle grey from the beginning. And all this can be used, whether it be roofs or walls, or as you can see there, rainwater systems. The quartz zinc can be used for that. And here's a few examples. There's Borough Viaduct with the Shard behind it. Then in the middle, top is actually some housing in Dublin. That's a renovation using rain screen panels. A school in Stockport that was extended, so a large extension. And on the right, actually, a project, a university building in Chicago over in the US. The first pre-weathered zinc that we produced, though, was anthrazinc, which is sort of like has a very similar aspect to slate, and that was first produced in 1979. So it's been around for almost 50 years now, and it was originally used as a flashing material for slate, because installers used to paint the zinc because clients didn't like the shininess of the zinc. The problem with painting zinc in situ is that the paint peels off, doesn't look great. And architects asked us, could we pre-weather zinc? And we came up with this, as I said, in 1979, initially as a material just to be used with slate, flashings, gutters, and that sort of thing. But over the years, it's become a material in its own right for roofs and walls. These are both actually sort of social council housing type buildings, one on the left in London and the other one on the right in a suburb of Paris, both using anthrazinc, but quite different architectures. And again, anthrazinc, this is a pub on the left and the University of East Anglia in Norwich on the right. And I mentioned the engraved zinc, Azengar. This is a building on Brighton Beach, literally. And as you can see, zinc is pretty good in marine environments. It deals very well with salt. The only slight issue is if you do have a non-rinse surface right by the sea, you can get a bit of staining from the salt. But if it's rinsed by rainwater, it performs really well. The salt staining is not really a corrosive problem, but aesthetically, it's not very attractive if it just can't get rinsed at all by the rainwater. And then there's pigmento, which is zinc, which has a mineral pigment that's added to the pre-weathering. It's a little bit like looking at zinc through tinted glasses. You can still see the texture of the zinc. They're not bright, vibrant colors. They're fairly discreet. And you can use them for all the systems, so that it be roofing, wall cladding, standing seam, rain screen. It doesn't really matter. All of those are possible in the pigmento range. And this is a project that was done over 10 years ago, Godson Street near King's Cross, Islington. It's very accessible. It shows zinc that's been up for a number of years in lots of finishes. So if you are in London and want to see zinc in lots of finishes all at once. This is a good place to go and have a look. And we're always extending the finishes. This is the same principle, that's slightly darker, so dark zinc with a very slight red colour and with a very slight blue colour. And we've even done bespoke colours. This is on Oxford Street in central London. Now, coming to a retrofit in the Isengard, the engraved zinc. This is a building in Burgundy in France, which started life off as a leper colony, of all things, several hundred years ago. But it's been turned into a cultural centre, and on the left you can see how the existing building's been renovated. And then the bottom right is sort of what they started with, and then the top right is what it's become. And you can see there's this connection building which has been clad in zinc. The minerality of the Isengard engraved zinc really works well with the limestone, so it's sort of a nice combination. You've got a sort of a modern contemporary style with obviously something that's much older. And you can see that the panels on the left there, they've changed the center to center of the panels just to give it a little bit more texture. And there on the right, you can see the inside of that new part of the building with some really interesting windows. All of those windows on the outside are flashed with the same zinc. Zinc can be used not just for the panels, but obviously all for the flashings and the gutters and the downpipes. It's a complete system. So zinc can be used for roofs and walls. Standing seam is really what's mostly used for roofs. We did mention batten cap. There is a minimum slope of 3 degrees and a maximum length of about 13 meters. Metal, including zinc, expands and contracts, and you go beyond 13 meters and that gets difficult to manage. Talking about standing seam, we're talking about a 25 millimeter standing seam. It's a fairly discrete seam. It's not an industrial sort of rib. It doesn't have stiffeners, so it's quite a discreet panel. And this is a project on the Marylebone Road, again in London. The Which headquarters, Georgian Terrace, which has been extended upwards with a zinc-clad sort of meeting area. Again, sort of mixing some older architecture with some quite contemporary stuff. Really works very nicely. Just a word on build-ups. Both cold roofs and, as you're going to see, warm roofs are possible in zinc. Cold roofs are where the exterior skin is vented. There's a space between the insulation and the exterior skin, whether that be at the roof level or at the loft level. It doesn't matter. These are vented roofs. And that's typically the build-up. You'll see there'll be zinc sitting on quite often timber. There are other options with a vented cavity underneath. The vented cavity is not to deal with water ingress from the outside. It's to deal with condensation from the inside. And a warm roof is possible. This is where you have your insulation above the structure, hence the term warm roof. So typically the zinc is sitting on insulation. So you'll have your structure, a vapor barrier, which is absolutely fundamental. It has to be an aluminium bitumen backed vapor barrier, not a VCL, not a polythene film, insulation, breather, membrane, and then bearing plates, stainless steel bearing plates with the pegs that go through and fix the zinc back to the structure below with a very limited thermal bridge. And there's a number of options, and including ones that have a BBA certificate. Another retrofit project, Lots Road power station that was closed just over 25 years ago now, and has been renovated into mainly flats. And this has an actual bespoke pigmento bronze finish that probably complements the brick quite nicely. I mentioned batten cap a few times. On the right is an old church that was re-roofed with a zinc batten cap roof, church up sort of near Shrewsbury. A batten cap is very similar to a lead roll, so it's a U panel with a timber batten and then a flashing over the top. And this is the Wallace Collection in West London. Again, quite an old building, combined sort of a little bit in the Parisian style, a mansard in slate and then a batten cap zinc roof on the top, with ornaments in zinc, and you can see the bullseye window there in the quartz zinc. And you'll recognise this if you're a cricket fan, although the nursery end has grown a bit since this photo was taken. This is on top of the pavilion, batten cap panels. One thing that's important to note is that zinc is quite light. It weighs about 6 kilos a square metre, so much lighter than lead. The structure wouldn't have coped with lead here, which would have probably weighed about 25 or 30 kilos a square metre. Oops, sorry, jumped for a bit quick. Do that. Just going to go back to where I was. Right, so just moving forward now. Now on facades, there's lots more options of panels, including rain screen panels. Standing seam facade isn't a rain screen, but there are rain screen options. But typically, you'll have sort of 3 types of joint: the standing seam on the left, a flat lock type joint, so 2 hems that are locked together, and then some sort of reveal type joint, which is more commonly used with rain screen. So the standing seam on a wall is really a roof on a wall, and that can be fitted to plywood. The zinc itself is A1. All finishes are non-combustible A1, but it is possible to replace the plywood with a steel deck, taking anything that's combustible out, using maybe only A1 and A2 materials, but the zinc itself, as I said, is A1. And there's an image showing the steel deck before the zinc's applied. Obviously, zinc and galvanized steel are completely compatible. So galvanized steel is just steel covered with zinc, so there's no compatibility issues there. As far as widths are concerned, maximum 600, that's really for youth roofing, and 430 for more wall cladding, but you can sort of play on panel widths, as we've seen on other projects, to give the facade even more texture. And the flat lock panels, as I said, it's really just panels with 25mm hems that are locked together, and that can be rectangular, diamond shaped, square, but they're all essentially flat lock panels. And this is a project that was done in Stirling in Scotland, which uses flat lock panels in anthrazinc on the wall and a standing seam roof. It was an old engine shed and has been turned into a cultural centre. Again, a combination of quite old architecture with something that's very contemporary, really working very nicely in the geometry of these buildings is very, very efficient and effective. This is a stamped shingle called Attica, and here there's an extension being done on a domestic property, creating a quite an elegant extension. Mentioned rain screen a few times. So rain screen is really where water can ingress through the panels, which is fine. There's a cavity and it can drain out at the bottom. So the interlocking panel is probably the most commonly used rain screen panel. And this is a project that was done in Bilbao with Philippe Starck, the designer sort of architect, and it was extended upwards with these sort of rain screen clad pods, and on the right there you can see the interior space, which is very elegant. Sine wave. Obviously, we haven't invented sine wave or corrugated. It's just corrugated zinc. This is one of the few systems where you actually fasten through the zinc and the fastener's visible, so it's absolutely fundamental. That's a stainless steel fastener. And this is a project in Belgium where an old industrial building was reclad in sine wave quite effectively. And here you can see the facade, which is sort of really been freshened up, and that's one of the flats on the right there. Which staying with sine wave corrugated, a doctor's surgery in Hackney in East London was extended upwards to, there's still the doctor's surgery, but there were some flats that were built above. It's actually called the Zinc House, and this uses corrugated anthrazinc, some of which has been curved around the balconies and some of which has been perforated. So it's quite a simple system, but it does look very, very efficient, elegant. Just a word on flatness. Nothing's completely flat. If you look at the glass building, a reflection, it's quite wavy, but different systems will have different levels of flatness. Standing seam on a wall will not be completely flat, although we recommend using 430 maximum and using 0.8 thickness. It still won't be perfectly flat. And on the photo on the left, it was taken with the sun at an angle, which is making it look worse. But this is just to show you there are, as it were, horses for courses. The project on the right uses a rain screen system where you've got heavier gauge zinc. So if flatness is a real critical issue and you want zinc, standing seam might not be the best option. This is the Port Authority building in London. Again, this photo was taken a few years ago because the view of a few towers have been added to that view between the walkie-talkie and the gherkin and the cheese grater. This was an old, as I said, an old Port Authority building. I think it's a hotel now, and a rain screen roof was created on the top. So a rain screen roof means that the water can penetrate through. And on the left there, all those black lines are effectively gutters. So quite a complicated roof, but it's quite interesting. And you can do other things. You can perforate, as we've seen, but you can also stamp zinc. That's an artist studio on the Isle of Skye. Mentioned weight earlier. This is Poundbury. I won't get into the pros and cons of Poundbury, but the project does show a sort of a balcony balustrade, which was initially going to be stone, but when the architects were looking at doing the dormers in zinc, they saw that we could do quite a lot of interesting things with zinc as far as folding it, spinning it, soldering it, and create a balcony. It was, as I said, going to be stone. The advantage of the zinc is it's far, far lighter, making quite a significant saving on the roof structure. And zinc gutters, sometimes we see projects with a lovely zinc roof and then a PVC gutter, which is a little bit sad. You can use the same gutters, whether they be half round, rectangular, or internal gutters with all the accessories, the end caps, the elbows, and so on and so forth. And it's possible to clamp on PV panels. This can obviously be done on retrofit, but also on new build. Panels can be adhered to the zinc. The clamp-on system maybe makes it easier to add and to remove. The only issue is we do need to look at the shear stress. If you're clamping something onto the standing seam, you need to make sure that that standing seam is not being put under too much of a load, and that's something that we can look at for you. As far as certification goes, plants are ISO. We also have EPDs for all the finishes, and as I mentioned earlier, the BRE state a lifespan of 100 years with limited maintenance, and it is fully recyclable. We've also done a number of B-roof T-force tests showing no flame penetration or spread, and as I said, the material itself is A1. Zinc is not compatible with everything. As far as metal is concerned, the big thing to avoid is copper. If copper's beneath the zinc, there's not a problem. Some very acidic timbers can stain zinc. Again, if they're beneath the zinc, it's not a problem. So if you are doing something where other materials have been, where the water's going to run across the material onto the zinc, maybe have a chat with us and we'll let you know if it's going to be okay. This is not a retrofit, but it's an interesting project or two projects, both in New Orleans. This is going back to 2005 and the Katrina disaster, where there was a significant hurricane and flooding. The panels on the left are interlocking panels, which were pretty much no damage at all. On the right, standing seam, and you can see that the windows have been blown out and the flat roof has been peeled off, but the zinc resisted extremely well. So it actually has been hurricane tested. And zinc is all of the zinc that we sell in the UK is all made in France, but it's stocked in the UK, so it is available. Price does depend on complexity, the nature of the project, the size of the project, the location, and a number of things. But sort of between 150 and 200 pounds a square meter supplied and fitted is sort of what you'd expect. Now that means the panels, the installation, not the substrate, so not the insulation and the timber or metal, but the zinc panels supplied and fitted, sort of between 150 and 200 pounds a square meter, but it will vary depending on project. James mentioned the importance of installers. Zinc is not a standing seam, and facades shouldn't be installed by general builders. There is a network of installers around the country, and in particular VMZINC at Work partners, of which there are 65 across the country. These companies obviously understand all our recommendations, the nature of the flashings, the build-ups, cold roof, warm roof, panel size, and they can also offer a 50-year material warranty on the projects. I mentioned UNESCO. I think it is important to stress that we sometimes criticise trades in the UK, saying they're not as good as Germany or Switzerland or France. There are undoubtedly people that are doing things they shouldn't be doing, but there are also very, very competent, well-trained companies and companies that do spend time and money on apprenticeships. So there are some excellent companies. As I said, we do have a list of 65 companies across the UK and indeed Ireland, VMZINC at Work. We have a further 65 or 70, so sort of getting up to about 140 companies in total. The other ones are recognised, so they also have knowledge of fitting VMZINC. Going back to the biggest retrofit, Paris. If you watch the Olympics back in 2024, a lot of the events were had a backdrop of Paris, and therefore you would have seen lots of zinc, whether it be the quayside of the Seine or a high level view. You would have been looking at lots of zinc on those images. We can supply a lot of information, whether it be literature, samples, MBS specifications, BIM. We have a large library of CAD drawings, and obviously we can do face-to-face discussions about specific projects. That's something we're very happy to organise. So please let us know, contact us if you do want us to talk about a specific project. That's a project, actually, an old army barracks in Turin that, as you can see on the bottom right, that was a little bit the worse for wear, and it was sort of massively renovated, and then around the whole of the building, a perforated screen was installed using zinc to sort of almost give it sort of an ethereal type feel, take away the image of a barracks. The nice thing about zinc is obviously you perforate it, you're just exposing more zinc. You're not exposing anything else. It's just zinc. So that's pretty much finished. But just before I go, I do want to mention that we do offer, for the last 2 years, we've been able to offer copper. Now, copper and zinc, as I mentioned, don't actually get on with each other as far as compatibility, but they are designed and installed in very, very similar ways. Copper's red, zinc's grey, but the way they're installed, the techniques and systems are almost identical. So what you can do in copper and what you can do with zinc are very, very similar. And there's as with zinc, there's a number of pre-weathering treatments that we can do with copper, including artificially creating the copper that looks green. Right, that's it from me. I'm going to hand back to James for hopefully a few questions. Thank you very much.
Thank you so much, John. What a great, elegant, understated material zinc is, eh? Very popular with architects, as we know, or many. It's interesting you've moved into some new shades there with the copper side of things, but we're going to stick to zinc, and we've got some practical questions which have come in, which is very very helpful. And you have talked about roof build-ups, but and also what zinc's not compatible with. But we've got a question from Ken, who asks, what is the recommended makeup for a modern, highly insulated roof/wall construction, and that's maybe not something you want to put your name to legally. But do you have any thoughts on a recommended modern highly insulated wall?
Well, no, I mean, I think it's an absolutely fair question. The traditional way of installing zinc, and it would be with copper and lots of metals, is on a timber ventilated deck. That's what's sort of been done for 200 or 300 or more years, and that still works extremely well. There's absolutely no problem with doing that at all. But over the last, I would say, since the mid '90s, we started getting involved in not in warm roofs in about 1995, so over 30 years ago, and they've become more and more popular. Mainly because you reduce thermal bridges, you can have a much better U value,
The
and
insulation above the rafters, correct? Yeah.
so you basically have a roof structure which is going to be essentially the same as it would be whether it be cold, but above the rafters you're going to have some sort of deck which could be timber, could be metal, and then above that there's going to be a vapor barrier, and then your insulation, and then your breather membrane, and then your zinc. So it's a sort of a sandwich above the rafter. Sometimes people think that a warm roof is thinner than a cold roof, which isn't entirely true, because you're normally putting your insulation entirely above your rafters, hence the name warm roof, because the roof structure is warm. And that does give the advantage of having a thermally very efficient roof, and the vapor barrier also acts as a very good air barrier.
Right.
So, from that perspective, if you're really aiming at high performance, that's probably the way to go. But there's nothing wrong with the traditional cold roof either.
Okay. Question from Bart: do we really need this sandwich approach for deck insulation when using zinc or any metal cladding? This means cladding on top of OSB, on top of insulation, on top of the vapor barrier, on top of the deck board, and finally on top of the rafters. That's quite in depth, but do we? What's your view on whether how crucial that is?
I mean, the build-ups are. You have to get the build-ups right. It is it's a very important thing, and number of years ago, we started spending a lot of time with installers talking about roof build-ups. Going back maybe 15 or 20 years ago, there was a sort of a bit of a thought an installer would come along and a builder built the build up and they'd put the zinc down and they'd do a very good job and walk away. And we said, well, you are taking responsibility for what you're putting the zinc on. So even if you're not doing it, you do have a bit of a duty to make sure it's right.
Yeah.
And it has to be right, whether that be from an installer's point of view or a designer's point of view. Now, when you're doing a cold vented roof, you've got a vented cavity between your deck and your insulation, and those two things then sort of isolate from each other. So I'm not saying you can't make any mistakes, but it gets more difficult to make mistakes.
Right.
When you're doing a warm roof, every element really has to be looked at. So the vapor barrier will affect the insulation, the zinc will affect other elements. So everything becomes quite important. So though in a warm roof in particular, it is critical to make sure that all the elements are correct. And we have a number of build-ups that can be chosen. And if an architect does say, right, well, this is what I would like to do, we can always look at it. So if there is a very particular build-up that somebody is interested in using, let us know. We'll have a discussion. We'll see if it works. We prefer to look at it when it's on the drawing board rather than when it's on the roof.
But as so often, the ideal thermal solution is possibly also the most complicated to do, or requires a lot of thought across all of those elements, as you say.
Yeah, exactly. It might not be complicated. It might need a bit more thought about how one product or element might affect another. Yes.
Okay. A question from Edward: how do you overcome dealing with roofs with a slope less than 3 degrees in a retrofit context?
Unfortunately, that's quite simple. We would not recommend zinc being used on a roof that's less than 3 degrees.
On a flat
We
roof?
probably wouldn't recommend any metal, because the problem with if you go less than 3 degrees,
Yeah.
However well things are done, water starts ponding. And when water starts ponding, two things happen. One, you'll get staining, and two, sooner or later, you'll get some sort of water ingress. So metal generally, but certainly zinc and copper, are not flat roof materials. So 3 degrees as built is really the minimum. If it's less than that, metal probably isn't the product for that renovation. It can't do everything.
And you won't see it from the ground either.
No.
So we noted, sorry, question from Stephen. We noted some small areas of white rust on a condition survey on a roof that was less than 10 years old. How can they check if this is a more serious issue with the roof, or poorly stored zinc rolls that may have got wet?
Yeah, good question about white rust. So white rust is basically zinc that's been exposed to water without enough air getting to it. Without getting into the sort of serious chemistry, zinc reacts with water um, to form zinc hydroxide, which is white in aspect, and then it reacts with CO2 in the air to form zinc hydroxycarbonate, which is a very even grey patina. So it can happen, as was stated, through poor storage. It could happen because of there just might be an area where there's sort of water trickling over something, and it's just always wet, which wouldn't be ideal. It can also happen through underside corrosion if the substrate is permanently wet. That's
Hmm.
more serious. If it's sort of, I mean, one way of knowing if it's serious, if you go up to a piece of zinc, whether you can touch it or on a roof walk on it, and it's got a little bit of a spring to it, then the integrity is absolutely fine. If
Right.
it feels like you're walking on eggshells, that's not good. Now, that will not happen on a wall ever, but it could happen on a low slope roof if the substrate is wrong. So
Okay.
again, we'd be happy to look at that in a bit more detail on a specific sort of case by case
To find out if
scenario.
there's an actual serious damp issue on the roof. Yeah. Okay. So an anonymous question. Nothing too controversial. What is the tested backing material behind the standing seam zinc for a building that requires non-combustible wall constructions? If that makes sense.
Well, I mean, if you're doing a building over 18 meters, or you're doing a building under 18 meters but wanting it to be A1 A2, we'd recommend a galvanized steel deck. We are looking at using cementitious boards for substrates, which, if you use something called Zinc Plus, which is zinc with a coating on the underside, is completely compatible. There's no
Yeah.
problem about the zinc and the cementitious board. The only issue is we're still looking at pull out over a long time. So obviously, when you attach zinc to a substrate, you've got dynamic loads because of the wind, and we want to make sure that will perform adequately over not a period of a few weeks or months, but over many years. But
Okay.
normally, at the moment, it would be a galvanized steel deck.
Right, on a non-combustible A1
Yeah,
wall, for example.
yeah.
Right, thank you. Just a couple more. In terms of compatibility, would you say, this is Alan's question, would you say that penetrations, sorry, in terms of compatibility with penetration, for example, to a roof, would you require a specific type of flashing, for example, a wood, for installing a wood burning stove flue? It's quite a niche one, but
Well, first of all, the flashings can be zinc.
yeah,
And zinc can be soldered. As far as a flue, this has come up a few times. Zinc melts at 420 degrees centigrade. Now, if there's any chance of the exterior side of the flue getting to a temperature not even close to that, I would say there would be a fire risk in the roof, not particularly for the zinc. So really, flues should be insulated.
mm,
Now that could be with a double skin and rock wool in between. But we would be worried if your exterior flue is going to be getting up to 100, 200, 300 degrees, not necessarily for the zinc, but the overall flue. So really, if the flue's been properly designed and installed, flashing it with zinc
think
shouldn't be a problem.
it's feasible. You don't need lead, for example.
Well, lead would have the same issue. Lead's gonna. Really, you shouldn't have anything on going through your roof which is going to be at 200 degrees, which is exposed to whether it could be rafters or anything. In that case, it really needs to be, the heat needs to be insulated.
Okay. David asks, what is the, well, I think you've probably covered this. The minimum pitch roof is 3 degrees,
Yeah,
right?
yeah.
Ken, I think possibly the same Ken, is clearly very invested. Are there any problems that come up again and again with zinc? No problems.
No, I mean, no. I mean, there was a. I mean, sort of. I suppose could give a very very long answer to this. There are some situations where people want to use zinc in inappropriate ways, and one of them would be under 3 degrees.
Yep.
Sometimes there are issues about wanting to use too big a panel. That creates issues about flatness. It can create issues about wind loading. The issue of substrates was an issue 10 or 15 years ago. I think through our work with VMZINC at work installers, it's been massively reduced. I'm not saying it never comes up, but substrates are far better designed and installed than they were maybe a few years ago. So we tend to have less problems with underside corrosion. So that hasn't. I'm not saying it never happens, but it's very very rare now.
Mm.
So there's sometimes trying to use zinc. We understand that designers, architects want to push the boundaries. I mean, that's what should happen with good design. Sometimes there are boundaries that we struggle with, but I mean, it's
The nature of boundaries. Yeah.
you can't do everything.
Yes. I wanted to ask as well, are they specifying natural zinc much for retrofits? That doesn't have a performance implication.
Um, I mean, that doesn't have a performance issue at all. Natural zinc, it will perform exactly the same way. I would say the quartz and anthra are probably the two finishes that are used most in retrofit.
Right.
Maybe it's because of the sort of aspect, the sort of more matte aspect that fits in with maybe sort of brickwork and some other materials.
Yeah.
Those are probably the most commonly used, but
Okay. And we've got one or two more just before we finish. Um, zinc is pretty good on embodied carbon, as I understand it. What Ella asked, what is the life cycle like, especially from a sustainability point of view?
um, I mean, I suppose the main thing is that when you put it up, it lasts for 100 years or more with very, very limited maintenance. I mean,
Yeah.
it's worth the clean out a gutter, but you don't need to go up and paint. You don't need to, there's no requirement to wash it down. As I said, cleaning out gutters are always a good idea, but the maintenance is I'm not
Minimal.
saying it's zero, but it's pretty low.
Mm.
Once the zinc is, let's say an old zinc roof in Paris that's going to get renovated, the zinc never gets put into landfill. It'll always get recycled, and in France, it's pretty close to 99%. So there's almost no. That zinc is then used for, as I said earlier, galvanizing, brass production, or new zinc sheet. We are currently redoing our EPDs, and that they have improved for a number of reasons. We're going to be hopefully issuing those in a month or two. We also have a product called Azengar, which 3R, which is entirely made from recycled zinc. So that's we're going to be launching it in the next few weeks actually, and that uses entirely recycled zinc, so it doesn't use any new virgin zinc at all. So
Right.
that from a life cycle analysis perspective would be even better.
Fantastic. I think there are two more questions, which we'll quickly rush through. Bart asks, how is the zinc fixed to the substructure? I think Bart's following up. Uh, he says, our builder insists on the top OSB board being fixed to that. Otherwise, screws go to the deck below, creating a cold bridge. So,
Well, I mean, there's a couple of things there. We don't really. I mean, we know OSB is used, but OSB doesn't have quite such good pull out as plywood or just solid timber.
yeah,
So OSB is not really what we'd recommend. As far as it depends on. I mean, if OSB has just been put over rigid insulation, that's again not what we'd recommend. So maybe Bart, maybe get in contact with us and just sort of explain exactly what you're planning or what your builder's planning, and what we'll sort of say, yes, that's fine, or no, it's not, and what we'd recommend in that specific situation. Because I wouldn't want to give sort of generic information on a specific issue if we want to make sure it's right. So Bart, don't hesitate to get in contact with us.
okay, fantastic. And then, last but not least, do you have a set of DWG details for the non-combustible A1 rated build-up?
Yeah. Yes, basically. We've got a set of details where zinc is put on galvanized deck or interlocking panels on cladding rails. And we have a sort of a test showing the overall build-up is A2. Having an A1 overall build-up for a facade, I think that's unlikely, because there'll always be people who will take sort of elements, gaskets and so on and so forth, that are going to not make it not completely non-combustible, but limited combustibility. But to answer your question, yes, we do.
Fantastic. Well, loads of really good in-depth questions, and thank you so much for your very cogent responses to that, John. And it's a great material, and there are so many ways perhaps people aren't aware of it being feasible in retrofits. So
Absolutely.
yeah,
Well, anyway, thank you very much, James. It's been a pleasure, and
thank you
hopefully the
for
rest of the morning will go very well.
thank you very much for coming on. Cheers, John.
Thanks, James.